First question here is from Blake. In episode 108 of the podcast at 23 minutes, you briefly discussed protecting crops from spring frost with foliar applications. I'm located in central Pennsylvania, and apricot flowers are often at risk of being frozen. What recommendations do you have to protect them, and what AEA products should I be considering to increase protection? Blake, this is a very good question. There are two approaches. Well, there's a couple of different possibilities when you think about frost protection and using nutrition management to increase or to reduce the freezing pressure or freezing sensitivity. I'm a little bit sleep deprived. I hope that doesn't come through too much here in the conversation. So there are two ways of thinking about this. First, you can do the best way is to reduce freezing pressure or freezing sensitivity with fall applications before you go into dormancy. And the second approach is that there are some limited things that you can do with foliar applications in the spring, but the greatest benefit the greatest opportunity is with fall applications. So with fall applications, there are different materials that have a positive effect. C-stem is known to have a positive effect. Seaweed's effects on increasing reducing frost sensitivity have been known for a very long time. But in general, the approach is that you want to do three things. One is you want to increase the concentrations of electrolytes in the sap of the buds. So just as the way if you have a high salt content in a solution that lowers the freezing temperature, that's a function of electrolytes. So your common electrolytes in buds would be potassium is one, magnesium is one, sodium and chloride you want to avoid having too much of. And then there is one, if you are not an organic grower and you manage this very carefully, you can also use urea on some crops. There's some tree fruit that don't lend themselves well to this practice, like apples. But if you do a very late season application of urea within the last 2 or 3 weeks of dormancy, just before leaf drop, that urea can move into the buds, and there isn't time for the plant to metabolize it, and so it remains stored as urea inside the bud, which gives the bud a very high electrolyte content. So that's one possible approach. Another approach or another pathway is to simply increase the sugar content of the buds. And again, you have a similar effect as sugar content goes up, or as overall, you could also say as an analog, as overall plant health goes up, then your freezing sensitivity is going to decline. Then the third pathway is to have very strong, robustly strong cell membranes and cells that are packed with nutrition. And this connects most directly from a practical management perspective with applications of trace minerals, particularly zinc, manganese, copper, boron, and in some cases with some crops also iron. So the approach that I would suggest is that you begin in the fall, preferably there's no downside to starting earlier, really. There's only, you get benefits from starting earlier. So you could go as early as 6 to 8 weeks before dormancy. You could even go during the growing season and simply build up the tree's levels of trace minerals. Make sure that it has generous trace mineral levels, and that is going to result in increased reducing freezing sensitivity. But if you miss part of the growing window, simply starting 6 to 8 weeks before dormancy and putting on trace mineral applications, the rebound trace minerals, putting on C-stem applications, and customizing whatever else is needed based on sap analysis. You may also need higher calcium levels, perhaps you need lower potassium levels, but really fine-tune in your nutrition levels based on a sap analysis, and that will result in reducing freezing sensitivity. That's the surest pathway forward. If for some reason you bypass and miss all those opportunities, you can still do some applications in the spring. Even before dormancy break, trees do absorb these nutrients through bark to some degree. And so you can still have an effect with spring applications, but the fall applications are the most effective and the most powerful. Question from Jeff Hatfield. Hi, Jeff. Do you have any suggestions for mitigating clubroot? We grew great brassicas for the first 10 years on our vegetable farm. The last 7, we've been trying to rotate around those soils with some success, but even the wild mustard has signs of the disease. Um, yes, Jeff, there is an answer for this, and it's escaping me at the moment. If my memory serves me correctly, clubroot resistance is associated with elevated levels of manganese and boron, but it's been a long time since I looked at that. The reference for that would be the first edition of Mineral Nutrition and Plant Disease. I don't know if it's also addressed in the second edition or not, but that is reasonably certain it's connected to those 2 trace minerals and possibly also to phosphorus levels. Um, and this is kind of a slight sidebar, but one of the things you might want to consider experimenting with is not just addressing mineral levels, but also inoculating these brassicas with BioCoat Gold. And this is actually, it's no longer odd because now there have been several papers published on this, but over a decade ago, we started observing that these brassicas benefit when there are mycorrhizal fungi populations in the field. They supposedly do not associate with mycorrhizal fungi, but they do benefit. There's very clear, distinct benefits from a disease resistance and an overall crop performance perspective when we inoculate them with mycorrhizal fungi. So it's an inexpensive application, and it could be a significant contributing factor to giving you increased disease resistance. So if you want to dig deeper into clubroot specifically, please reach out to our team at AEA, and let's dig into what the peer-reviewed literature says, because I'm reasonably certain that there is literature out there on what mineral profiles are associated with clubroot, even though it's been a long time since I read those. Question from Sebastian. Any recommendations for plant nutrition management or other strategies to reduce the garden symphyllin root feeding would be welcome? I had this question once before years ago, and the conclusion we came to at that time was that when we provide the plants with high enough levels of boron and high enough levels of iron, the root feeding goes away. The population didn't immediately go away, but the root feeding ceased to be a problem. This question I'm not quite able to make heads or tails out of. There's a question from Larry Johnson. John, you always tell us to add calcium, not phosphate, to our crops. I don't know that that's necessarily true. It's not that we don't add or don't make recommendations for phosphorus, because we certainly do. What do we do when the calcium levels are at 4,000 to 5,000 parts per million and test very high? I'm assuming you're asking about soil. And the implication that I'm gathering is you're suggesting that you don't have good phosphorus availability from your soil. So if that is the case, increasing phosphorus availability from the soil is a function really of microbial activity, particularly mycorrhizal fungi, along with some other phosphorus solubilizing bacteria. I would suggest that you consider, if it makes sense in your rotation, consider 2 possible cover crops. Oats and buckwheat are both known to be particularly effective at solubilizing phosphorus with their associated microbiome. Also be sure to use BioCoat Gold as a root inoculant. And we have a new product that we haven't really announced or launched in any significant way. It is going through the registration process. It's available on a state-by-state basis as it's moving through the registration process at this point, and that is a microbial inoculant called Santerra. And one of the effects that growers report when they apply Santerra is that their phosphorus levels on sap analysis jump significantly, and they get much better phosphorus availability. So that would be something to keep an eye open for. Question from Mark. Would it be possible to explain the differences between how potassium and boron move sugars around the plant? I'm currently at the fruit fill coloring stage of wine grape ripening. I have elevated potassium levels in my sap, so I haven't applied any foliar potassium. How and where do generous levels of potassium move sugar through the plant and berries? Similarly with boron, how will luxury levels of boron affect sugar movement throughout the plant and berries at this stage of ripening? I'm having a hard time conceptualizing how these two minerals affect sugar movement in different ways. Thank you, Mark. This is a really great question. A long time ago, Gary Zimmer used to say that calcium is the trucker of minerals and boron is the steering wheel. And I'd like to use that steering wheel analogy and that trucking analogy in this scenario, but instead of using it or describing the terms of transporting minerals, specifically about transporting sugars. So the way that I would describe it is that potassium is the trucker of sugars. It is the locomotive that moves sugars around inside the plant. And potassium is also stored in the fruit along with the sugars that it has carried there. And boron, boron is, in some ways, it's both the steering wheel and it is the accelerator. So potassium that's present in the plant is going to move around sugars where the plant would desire to have them moved around naturally anyway with the natural plant senescence process or maturity process. And boron does two things. One is, or maybe as I think about this, is it the accelerator only and not the steering wheel? Basically, a boron application will speed up the sugar translocation process that the plant wants to do anyway. So let's say you're in a vegetative growth stage and in the early season, you're in a vegetative growth stage. You're not yet quite at the fruit fill stage or berry fill stage. When you have generous levels of boron at that point, that will speed up sugar transport to the new shoots and to the roots because those are the two major sugar sinks at that point. Later on, as you approach maturity, fruit maturity, then the boron application, generous levels of boron will speed up sugar transport into the berries, into the fruit. In other words, it just speeds up the carbohydrate transport of what the plant wants to do anyway. I hope that's a useful way of thinking about it. Question from Tucker. In wine grape production, Central California coast, there is this pervasive practice of disking the vineyard row with the goal of saving water. I know you're familiar with this seemingly backwards idea. And that's not just seemingly backwards, it is actually backwards. Idea of fallowing for soil moisture savings. Have you gained any further scientific reasoning as to why this would be wrong? Fallow fields saving moisture seems antithetical to the usual workings we observe in the innate design of creation. Tucker, that's an outstanding question, and answering it thoroughly would require 20 minutes. For the moment, there is some fascinating new research that is soon to be published coming from Gerald Pollack's work. Many of you may know that I'm a big fan of Jerry Pollack's work with several of his books, The Fourth Phase of Water, Cells, Gels, and the Engines of Life. Jerry has a new book in the pipeline that is going to be describing his very original perspective on how water moves in the environment, how water moves in the atmosphere, what triggers water movement in the atmosphere, what triggers water movement in the soil, and so forth. And I've only heard about this. I haven't read it. I haven't read any advanced copies, but having confidence in Jerry's kind of original insights and perspectives, I'm certain that it's probably going to be very different from anything we've read before. So I'm really looking forward to that. And I know that some of the pieces he's going to be describing will be describing the science, some of the science behind how this works. But I'll answer your question from the perspective of plant and soil microbiomes and quorum sensing and collaboration versus competition. So we have been kind of indoctrinated into this paradigm that plants are inherently competitive with each other. that they're constantly competing for water and nutrients, and we can only have certain plants growing, say crop plants or wine grapes in this case, at the expense of other plants. And that if we have grasses growing in our wine grape row, for example, then those grasses will outcompete the wine grapes for moisture and nutrients, and any presence of soil cover will come at the expense of the crop. I just started reading a fascinating book titled Sweet in Tooth and Claw. And it's too early for me. I'm too early in the process of reading it to be able to give it an endorsement or a recommendation. But the title caught my attention because it describes our challenged way of thinking and how we should be. The fact that in natural ecosystems, nature doesn't compete as a primary means of survival. The primary means of survival is collaboration, not competition. And the key mechanism, one of the reasons why we have gotten this so wrong in agriculture over the last 7 or 8 decades is a failure to understand the benefits of diverse plant species and diverse microbiomes. And I'm in danger here of spending too much time answering this question, but this is such an important topic. I'm going to take just a moment to talk about this, and perhaps we need to have a webinar on this topic specifically. We understand that different plant species, particularly plants from very different plant families, have very different microbiomes. So I'm just going to make up some hypothetical numbers here as an illustration. Let's say that we do want as abundant microbial diversity in our soil profile as possible. And in just a moment, I'll talk about quorum sensing and I'll describe why that is true. But if we want to build as diverse number of species as possible, let's just say that each plant from let's say each plant is associated with 500 beneficial microorganisms in its microbiome. So you have 500 plants, 500 microbes for an oats plant and for a buckwheat plant and for a rye plant and for a wheat plant and for a corn plant, etc. For the sake of discussion, we're just going to say it's 500 each. Then, if you want to build, let's say you want to build a population that has 3,000 different species in the plant supportive microbiome in the soil environment. You don't get to 3,000 species by adding 6 plants at 500 each when those 6 plants are very similar and have a similar and related microbiome. So if you wanted to add cereal grains, let's say cereal rye and oats and wheat, there's not a case of 500 plus 500 plus 500 equaling 1,500 because there's a great deal of overlap since those are all from the same plant family. To avoid overlap and to create the greatest microbiome diversity possible, you need plants from different family groups. So you need an oats plant with a buckwheat plant, with a clover plant, and you get the picture. You need different plant families to have as diverse a microbiome as possible. And the reason this matters is because of this phenomena called quorum sensing. Quorum sensing is in the absence of quorum sensing. In the case of a monoculture, let's say we have just wine grapes, or a monoculture, a corn crop, or any crop that is a monoculture. In this monoculture environment, we have a lower species diversity in the microbiome. And because we have this lower species diversity and we have a single plant feeding it, it's my understanding that it is relatively challenging, relatively difficult, and particularly in our agricultural ecosystems, to establish this phenomena of quorum sensing because our population diversity, our microbial population diversity is too small. What is quorum sensing and what is different when we don't have it? Well, when we don't have quorum sensing, these 500 microorganisms that are associated with a corn plant all behave as individuals. Each individual organism has to fend for itself. It has to protect itself, and it has to find its own food sources. But as that population diversity builds, and as I understand it, and I'm still learning about this, but as I understand it, there are two dynamics here. The one is population diversity, where you now have a diversity of plant families resulting in a diversity of microbiome, and also just total quantity, the quantity of microbially active carbon that's in that system that is able to feed and support these microbes. You at some point, you cross a threshold of total number of microbes in the soil profile and total species diversity. At some point, you cross a threshold in which this microbial community engages in quorum sensing, and instead of behaving as a group of individuals, they begin behaving as one community. And what this means is that instead of behaving as individuals, as an individual, each organism has to defend itself and has to find its own nutrition. But as a community, they begin taking on specialized functions. Now, one bacteria that is perhaps particularly good at solubilizing phosphorus focuses on solubilizing phosphorus only. And other organisms that are surrounding that organism will provide it with nutrition and will protect it from the environment. So instead of every organism being generalists, they now begin behaving as a community and they become specialists. And the whole community engages in quorum sensing and they behave as one organism instead of dozens of individual organisms or hundreds or thousands of individual organisms. When that happens, plants that are growing in that environment also no longer compete with each other, but instead they collaborate with each other. So what we're talking about is not just quorum sensing in the soil microbiome, but also quorum sensing and collaboration instead of competition and the plants that are growing above the soil surface. The classical example of this, one of many examples, is the demonstration plots at the Minokan farm a decade plus ago, where they grew individual cover crop species in monoculture plots, and then combined diverse species from different families together into a plot in a severe drought-stressed year. And the cover crops where there were individual species turned into toast and were very stunted because of drought stress, and where there were a diverse species, these plants were still green and thriving because they were collaborating with each other for nutrients, with each other in regards of nutrient exchange and also water exchange. So many of us, we've been indoctrinated into this thinking that plants compete with each other because we haven't had enough species diversity in our management system, enough families diversity to engage the ecosystem in quorum sensing. This is the foundational piece. If we want to have cover crop species within our vine rows or within any crop system that doesn't compete with the plant for water, but it's our crop for water, but actively collaborates and provides the crop with more water instead of less, we have to, we may need to be cautious about which species we include, but we must include significant enough diversity to achieve those benefits and to achieve those outcomes. So anyway, that was a very long answer to that question. I know I don't have that much time for other questions, but this is such an important topic for us to really understand and wrap our minds around. So thank you for a great question, Tucker. All right, that wraps up the questions that were asked in advance, and I'm going to go through those that have now been entered in here and seek to answer those as well as I can. First question is from Kenneth. Hi, Kenneth. How can we expect plants to function properly in drought situations and still maintain good yield? I kind of already partially answered that question because, again, it's collaboration. This quorum sensing is a key part of that. There are others as well. I'll get back to those. Could you also explain how drought conditions, stress affect a plant? Also, how can we transition away from using herbicides in grain crops and still have clean fields? As far as I know, optimal plant physiology as explained in the plant health pyramid cannot be obtained with the use of chemicals such as Roundup. Boy, Kenneth, you go straight for the jugular with good questions. So, to your first question, how can we expect plants to function properly in drought situations and still maintain good yields? Well, Obviously, it's possible that droughts can become severe enough and water can become so restricted that plants simply do not perform as well. But we have a webinar on YouTube that I think is titled, or in the title is are included the words water use efficiency. Maybe it's nutrition management for water use efficiency or something like that. What we've learned is that based on how we manage nutrition, we can greatly reduce the crop's requirement for water because some nutrients that are high in electrolytes, and nitrate is one particular example, greatly increases the plant's water requirement. So if you supply nitrogen in the form of in a form that doesn't convert to nitrates, let's say amino acids or perhaps urea as a foliar, you can actually greatly reduce the plant's water requirement. And there's other things that we talk about there in the webinar. Could you also explain how drought conditions stress affect a plant? The answers to that question are also at least partially included in that webinar, and I would refer you to that. So to your next question, how can we transition away from using herbicides in grain crops and still have clean fields? In my opinion, from my perspective, I'm sometimes disappointed about how narrow our thinking is in answer to this question. And this is not directed at any one individual, but just us collectively as a society and as a group of farmers. This conversation is so commonly framed in terms of options A or B. Option A is using Roundup. Option B is tillage. And I want to say, well, wait a minute. What about options C, D, E, F, and G? And many of us don't spend a lot of time thinking about alternative options because we haven't been exposed to them. We're not familiar with what they are. But in short, all of these other options, I think where the long-term answer is going to lie, not in tillage versus Roundup. This is not a binary choice. We have a lot of other choices. And the other choices are all related to our, what's the proper frame here? Not ecosystem management, but our farm and cultural management practices. So decades ago, a French farmer agronomist named Marc Bonfils developed a method for growing wheat year after year in the same field in a perennial cover crop of clover. Colin Seiss from Australia has developed a method for growing oats in a perennial pasture. In the podcast interview that I had with Sarah Singla from France, she described how they have constantly growing plants and that when they harvest one crop, they have their soil covered with such a strong mat of residue, they will go through and no-till seed into that residue. And they have constant crops growing, but they have, actually, I think in Sarah's case, she was still using very tiny amounts of Roundup in certain parts of her crop cycle. She was very careful to not call it a rotation because she doesn't have a specific rotation. She plants whatever she expects will thrive best next in that soil environment and in the residue context that she's managing within. My point being that also, if you look at Jason Malk and the work that he's doing with relay cropping, growing wheat and beans in combination, all of these various tools, these kind of these different ways of thinking about managing plants to collaborate with each other instead of to compete with each other, thinking about plant sequencing and the sequencing and the timing of how we plant species. For some reason, these are all conversations that we collectively, that we have these individual innovators who are doing really great things, have done really great things, but we are stopping short of really taking those to the field and implementing them, experimenting with them, figuring out what works in our operation. So I believe the long-term answer, the answer that we should strive for to your question, is developing a cultural management system that we plant crops in a particular sequence or in a particular combination with other plants, as Jason Malk is doing with soybeans and wheat, so that our requirement for tillage and our requirement for herbicides is both greatly minimized and perhaps in the future even entirely eliminated. This is the conversation we should be having and what the things that we should be thinking about. Question from Luke. How can I manage nutrition to prevent late summer fungal diseases in almonds such as rust or alternaria? Um, the These various diseases, both those that infect tree leaves and those that infect hulls, hull rot, and so forth, are for the most part, I'm speaking here in very broad, sweeping generalizations, and you can fine tune this specifically with SAP analysis. But in general, they're associated with three things. They're associated with excessive levels of nitrogen, excessive levels of potassium, and inadequate levels of trace minerals: zinc, manganese, copper, boron, molybdenum, cobalt, and sometimes they're also associated with low levels of calcium. So this is a very broad generalization, but what I can say with confidence is that when you begin using SAP analysis and you address nutritional imbalances according to SAP analysis, these fungal diseases are going to disappear. And I can say that with a high degree of certainty because we've just seen it happen over and over on so many different diseases and so many different plants. Question from Wayne. You shared in a meeting in Kansas several years ago about using boric acid to kill anything green, including Bermuda grass. I have not been successful yet. What am I doing wrong? Is it the water hardness? Wayne, if I recall correctly, I talked about the possibilities of this as a possibility and as an experimental, something that is experimental. We've had a number of different growers try using boric acid with varying degrees of success. In some cases, they have not been successful at all. And it seems the degree of success or not is relative or is related to the calcium, first of all, the calcium content in the soil and the calcium status of those particular plants. So when you have plants that really love calcium and absorb it from the soil very readily, it seems the more boron you apply, the more they thrive. And they thrive extremely. They become lush, incredible, beautiful plants, which is something that we should think about also transferring to our crops that love calcium, like cotton and other crops that really thrive with high calcium levels. So that is what we've come to up to this point. And in short, could you still eliminate those plants with high boron levels? Possibly. I don't know how high you would have to push it, but it would be very, very high application rates. High enough application rates to probably be unrealistic. Question from Chuck. Do foliar nutrient applications suppress the development of soil microbial populations the same way that soil nutrient applications do, such as N or P applications on soil suppressing those specific populations that would make those nutrients available? It's not my understanding that is the case, Chuck. I suppose if you applied such large amounts of nitrogen and phosphorus to the plant that the plant actually transmitted some of those out of the root system as root exudates, it might have that effect in a limited way, but you would have to apply very large quantities to achieve that. In general, foliar applications, particularly if they're well designed, and they increase a plant's photosynthetic capacity and they address what the plant needs are, they will have the opposite effect from what you're describing. They will actually increase soil microbial populations because there will be more sugars sent out through the root system as root exudates, and you'll get more rapid. You'll actually build soil. You'll build soil organic matter. You will build microbial populations, and your soils will cycle carbon faster when you use well-designed foliar sprays. Question from Ellen. Does seed flare mitigate transplant shock when used with seedlings instead of with direct planting? That's an interesting question, Ellen. I suspect it would help, but that's not really what it's designed for. If you were to use we have a transplant mix that we've developed that is specifically for reducing transplant shock. I forget exactly what the combination is off the top of my head, but if you would reach out to our team at AEA, we do have a transplant mix that we can put together that will help a great deal to reduce transplant stress. Question from Mark. Hi, John. I noticed that your new seed treatment product has higher rates of cobalt than the other nutrients in it. Are you happy to divulge why this is so and how you arrived at the rates of the different nutrients of this product, or is that a trade secret? Well, Mark, what do you think? Come on now. I give away so much information so readily, yet there's always the desire for more. So the only thing I will say is that we arrived at that combination based on plant performance. And will the formulation continue to evolve in the future? It had better do so, because we don't want to continue stagnating. So will the formulation change and be different in 3 years from now than it is today? Yes, I do expect it will. We have active experimentation ongoing, seeking to constantly refine and improve that formulation. And so it's going to continue to be refined, but I expect the cobalt level is going to continue to remain high. Question from Doug. Is it more important to first focus on air infiltration into the soil before biology? Also, do you ever look at what soil carbon to nitrogen ratios are? Should we focus on this? So to your first question, is it more important to first focus on air infiltration into the soil before biology? I don't see it as a first and second in sequence question, Doug. I see them as both simultaneously. You can only build soil microbial populations when you have good air exchange and good gas exchange. And yes, there are some soils that need tillage as a reset tool. They need aeration. They need to be deep ripped. When you have very compacted soils, depending on what your context and situation is, there are soils that need mechanical aeration as a reset tool. And then, of course, that also means we need to change our management practices going forward so that we don't recreate those and don't recreate that situation again. To your second question, do you ever look at soil carbon and nitrogen ratios? Not in any significant or meaningful way in our consulting work. Perhaps there's something that we're missing, although crop performance would say otherwise. I think it might be a useful indicator and give us some understanding of soil microbial populations and how to manage soil microbial populations. But I think we're rapidly getting to the stage, particularly with the DNA sequencing technology that is coming online, to measure microbial population dynamics directly rather than indirectly through an analog. So we haven't figured out, one of the things that I obsess over is using and collecting manageable data. In other words, data that you can make management decisions from. And the carbon to nitrogen ratio doesn't give us data that we can make management decisions from that we're not already getting from other places. So how we manage nitrogen applications differently, managing cover crops and residues and so forth, we're already making those management decisions from other indicators that we're getting that ultimately will lead to the same place. So it would, for us in our consulting work, it would be overlapping information, which is probably why we don't pay more attention to it. Question from Mr. Anonymous Attendee or Mrs. What is the best way to burn down an existing hayfield to no-till reseed other than Roundup? Would depend a lot on the plant species. And I don't have a good answer for you. It depends a lot on your crop and your economic setting and economic context. There are organic herbicides like Suppress, caprylic acid. There's a new organic herbicide called Demise. There are, depending on the scale and the crop that you're talking about, it is possible to get organic burn downs. And yeah, there is a need. There are now, I'm not sure the exact count, there's maybe half a dozen organic herbicides in the marketplace, of which one of them does go down and kill root systems, doesn't just burn off the top of the plant. And they tend to be pricey and are challenging to be economically, they're challenged to be economically justifiable for broadacre crops. So it depends a bit on what the context is. But if you want to no-till reseed, I just caught my attention that you used the word reseed instead of seeding. If you want to reseed an existing hayfield, then what about the possibilities of just mowing it or grazing it right down to the ground and reseeding into that at certain times of the year? Depending on the grass species, warm season, cool season grasses, and if you get the seeding at the right time of the year, you can reseed without killing the crop, and the new seeds will thrive very well. And if you want to dig deeper into this, I'd suggest looking into Colin Seiss' work on pasture cropping and seeing what the possibilities might be. Question from James. Can you speak about the difference between pH and EH? I generally concern myself with redox, EH, and I don't have to worry about the pH. I didn't know what EH was until I heard you speaking about it. James, to give you a true scientific answer is going to take more time than we really have the time for. But the way that I would say it is that we have been taught to think of pH as being one-dimensional, and in reality, it's two-dimensional. So what's a good analog for that? At the moment, I can't think of a good analogy. Are there good analogies in cooking? There's none that comes to mind right now. But in short, well, let's say it this way. If you're making a recipe and you want to draw out flavor, if you want to have ice cream that has a really good flavor or anything that you really want to draw out the flavor, optimal flavor is drawn out as a blend, as a combination of different taste factors. So you need a blend with a little bit of acidity, a little bit of sweetness, a little bit of saltiness. You need a combination of all three. If you have just saltiness, but no sweetness or no acidity to balance that out, then you have what I would call a one-dimensional recipe. So EH and pH are the same in that they are two-dimensional. You need both. Both need to be balanced. Each one influences the other. You cannot properly consider one in the absence of the other. And if you want to dig more deeply into this, I wrote a couple of blog posts on redox, and I referenced the paper that Olivier Houssan was the lead author on. Check out Olivier Houssan's work. There's a free course on kindharvest.ag where he provides about, I think, a 5 or 6 hour deep dive into understanding redox and pH as a paired unit rather than considering them individually. Question from Donald Mills. John, we're in Central. Let me see. How are we doing? 26 questions. I need to pick up the pace here a little bit. We're in Central Georgia soils, red clay, permanent pasture and hay. pH is 5.8. Soil is very compact. Plant roots are in the top 2 inches of soil. In addition to AEA fall soil primer, would you add calcium? And then you're asking about SoilWorks GSR dormant, or is lime a good addition for pH? I would definitely add limestone because with your pH of 5.8 and calcium at 500 per acre, I'm assuming that's 500 pounds per acre, and that you don't give any indications for CEC, but the short answer is yes, I would add soil primer. I would add limestone or perhaps gypsum. And if you want to get more specific recommendations, please connect with our team. And you might also want to consider, given the context that you're describing, if the plant roots are all in the top 2 inches of soil, it sounds to me like this soil is also a candidate for a tillage reset. There are subsoilers that you can take through pasture systems that do not disturb the surface residue at all. I'm thinking of the yeoman plow and the various knockoffs of the yeoman plow that are available here in North America that will go through the soil surface, through a pasture setting. They will lift it, raise it, aerate the soil, but not disturb the surface zone at all. Question from Ben. Do you know of any nutrient deficiencies or excesses that could lead to issues with squash bugs? How about issues with cabbage moth and brassicas? The short answer, Ben, is yes. There are specific profiles. They for both of these organisms. Well, Let's talk about the squash bugs. Squash bugs, because of their more robust immune system, can be associated with quite a range of different things. They can be associated with high chloride levels. They can be associated with low phosphorus levels, with low silicon levels, with low levels of zinc, manganese, boron, um, with low levels of molybdenum and sulfur and magnesium, or some combination of all of those things. So the best way to know for certain is to pull a SAP analysis and identify exactly what the imbalances are and address those accordingly. With cabbage loopers and brassicas, it will almost certainly be some combination of elevated levels of nitrates, low levels of magnesium, sulfur, and boron. Question from Luke: are there any negative impacts with using a boric acid product? I find that I have better efficacy with raising boron sap levels using a boric acid derived product versus sodium borate product in almonds. The form of boron that plants absorb most efficiently, let me clarify that statement. The ionic form of boron that plants absorb most efficiently is boric acid. But the better forms of boron that they absorb even better than boric acid and move them around inside the plant. See, the challenge with boron and calcium and manganese, particularly those three elements, is it's not just a question of getting them into the leaf. It's also a question of once they're inside the leaf, does the plant have the ability to move them around? And also silicon. So it's manganese, boron, calcium, silicon. Those four elements, if we put them on as a foliar spray, it's not enough to just get them inside the leaf. We also have to give the plant the ability to move them around. And boric acid excels at being absorbed, but it does not excel at being transportable. So the best forms of boron for that purpose are boron products which are complexed, and complex is the technically correct term instead of chelated for anions. So you need boron that is complex and can be transported inside the plant, which is why we recommend the use of rebound boron in this setting, in this context. So it's actually possible, Luke. What you might experience or observe is that you improve your boron levels in SAP analysis, but perhaps there remain to be wide variations between boron levels in new leaves versus old leaves. And perhaps you still have some of the challenges that are associated with low boron levels in the nuts themselves, such as hull rot and not enough calcium transport. And that can be a result of boric acid being very readily absorbed, but then just staying put where it lands rather than moving around. Question is from an anonymous attendee is, what are the typical steps and timeline for converting high-yielding corn cropland farmed with Roundup and GMO seeds to regenerative cropland? I don't know that if I can give you, and considering I'm trying to answer these questions quickly, if I can give you a simple short answer, because the answer is the accurate answer is it depends completely on your crop, on your context. What are your economic means? What are the soil conditions looking like currently? What are soil nutrient levels? What markets do you have available? What machinery and equipment do you have available? What is your internal, and the biggest one of all is, what is your internal mindset? How rapidly do you want to change? What is your comfort level with change? What is your appetite for risk in growing different crop types? So the answer is it can happen very rapidly. It can happen in a single or a couple growing seasons, or it might be a 5 to 7 year transition period. It's really a question of the context that you're operating within. Question from Zachary, an arborist in Atlanta. What would be your recommendation for generally, whoops, what just happened? All right, looks like we're still live and everything is still working. That was an interesting blink on the computer. What would be your recommendation for generally beneficial fertilization mix and frequency for clients who don't want to pay for SAP analysis. I'm aware that it isn't ideal and shade trees aren't your usual fare. I'm hoping that I can put together a mix of micronutrients that would be beneficial with a limited risk of harmful excesses. Yep, got it, Zachary. This makes sense. This is a common question that keeps coming up over and over. We have made tremendous strides in refining and improving our product formulations over the last 9 months or so, and are continuing to make some very rapid developments. We released a product called MacroPack this spring, and we also historically did have a product called MicroPack. And as we are refining those product formulations and figuring out how they best perform with each other and collaborate with each other, we are going to be putting together many, there's this, you're familiar with the idea of the Pareto principle that you get 80% of the results from 20% of your actions, or from 20% of your effort. And the situation that you describe is a very common situation. It's a common situation in market gardens. It's a common situation in fields or soils that have very highly variable soil types with a lot of soil diversity. And so we set out to create what is an overarching umbrella approach that gets you 80% of the results with minimal effort and with minimal effort. And so the result of that is that we are putting together this combination of MacroPack and MicroPack that is designed to be kind of a two-part solution that is used in collaboration with each other, and that addresses 80% of the possible scenarios that can come up and kind of covers all of your bases and produces a very strong plant response, almost universally across different crop types because they share so much common physiology. Question from Ryan. Hi, Ryan. For farmers who have been adding polluted biosolids, ouch, to their fields for veggies, hay, have you all been looking at pollutants in the soil, especially with the EPA PFAS regulations? A cattle farmer was shut down here in Michigan. We're working with Tineo to run trials at his farm in Brighton to see if we can help him remineralize or phytoaccumulate the pollutants out with humic acids and microbes. Yes, so short answer is you also, in addition to humic substances and microbes, you need to look at plants. And if you have a specific situation like the one you're describing, you need to identify plant species that are very good at absorbing those toxins and remediating them from the soil. And hemp is one that is known to have this characteristic. Based on some of the limited data that I've seen, I tend to suspect that giant ragweed also has this characteristic, but that has to be measured and quantified. And there are many other, if you do a simple search on Google Scholar for bioremediation of specific compounds, or actually not bioremediation, sometimes bioremediation, but specifically phytoremediation, there's a lot of research remaining to be done, but there's already been a lot of research on using specific plants to remediate various toxins. Question from Lonnie. We're having trouble with worms in raspberries and this year in our cherries. They get some spotted wing Drosophila. Is there a way to control that without pesticides? The short answer, Lonnie, is yes, there is. We have done this successfully on many different types of crops and different types of environments, ranging from blueberries and raspberries and strawberries, grapes and cherries. So the answer is yes. And it will require diligence, and it will require very good nutrition management using SAP analysis. So the short answer is yes, that it is possible. And I would suggest reaching out to the AEA team and digging into the specific details of what are going to be required for that for your crop and your context. Question from Keith. What does water hemp tell us about our soil mineral balance, compaction, glyphosate use, or other factors that favor water hemp growth? Can a specific cover crop provide those nutrients? That's a good question, Keith. That's exactly the right question to be asking. And I don't know an answer off the top of my head. The question that I would think about is, what plant family is water hemp in? And is there a crop or a cover crop or another plant species that is in the same family that we can plant. That's the first place that I would look, because many of these plants' reason for being is not, well, obviously there's kind of three dimensions. There is the soil physical dimension, compaction related, etc. There is the microbiome dimension of what does the associated microbiome look like. And then there is the mineral nutritional balance dimension. And people historically have tended to focus on that dimension because it was the one thing that was easy to measure and quantify. But the microbiome is also extremely important, and that is why having plants from the same plant family could be an effective tool. Question from Ellen. I mentioned BioCoat Gold as a root inoculant in addition to being a seed inoculant. Yes, it's both simultaneously. We use it as a transplant dip. We use BioCoat Gold in close proximity to root systems when we're planting roots as well as seeds all the time. Question from Marion. Hi, Marion. How much cobalt sulfate or other do we need to place on corn to delay senescence together with calcium silicate, silicon, amino acids, and other micros? As boron has the opposite effect, should we still place a couple of ounces to move sugars together with cobalt in high heat and drought in Bulgaria? Marion, there isn't a simple and easy answer for this question because it's going to depend on how much cobalt is in your soil profile. It's going to depend on your crop maturity. It's going to depend on climate and environment, crops, temperature, stress, and so forth. So I'm not really comfortable giving you a specific recommendation right off the top of my head, but I would be happy to have a follow-up conversation and pick up the conversation with you and see if we can make some specific recommendations on how you might respond to that. It's a very good question. Question from Tim. Can you talk about aminos such as amino proteins and amino sugars? Is this not the ultimate goal? As if biology has what it needs, it will convert raw nutrients into amino acids. It's a bit broader than that, Tim. It is true, and the ultimate goal from a nitrogen management perspective is to have plants absorb their 100% of their nitrogen requirement in the form of live bacterial cells. That is the ultimate goal. So, of course, those bacterial cells are going to contain proteins, peptides, amino acids, etc. And that's the best form of nutrition, nitrogen nutrition for a plant. Question from Kevin. We have a small apple orchard in Manitoba. We've been on the frontier of where apples are grown ordinarily, and there's little agronomic support of about 30 varieties of apples grafted onto Geneva or Vineland 3 rootstock. Trees are 3 to 6 years old. Main challenge is the last several years of drought has supported a major grasshopper infestation. Previous years, I resorted to cormorant and a 7 product, and nevertheless, the trees were badly defoliated in late August, which I believe is our lower tree buds set each fall as they try to push out fresh leaves in September. Ouch. I'm managing the orchard floor differently this season with minimal mowing, but I'm still noticing an increasing number of grasshoppers present. This is a great question, Kevin. I'd be very interested in helping you try to figure this out. I don't know if you have any SAP analysis data. You have a large enough scale with 8 acres. You have a large enough scale that SAP analysis is worthwhile and that you can send this to a laboratory that's economically worthwhile. So I would definitely suggest that as a tool because it will allow you to really fine tune in and focus specifically on what is needed. I would suggest that one of the elements you're likely do not have adequate levels of, and that you probably need to increase levels of, is boron. Perhaps also magnesium, sulfur, molybdenum within the plants. We would need to look at that. But I would suspect that those trace minerals, those minerals that I just mentioned, are probably the foundation of getting you to the point where your trees are less attractive to the grasshoppers than other plants that might be around. Could you describe a scenario where you want to limit calcium applications during cell division? I can't imagine a scenario like that. In a webinar years ago, you mentioned that there were very few examples of where you would limit calcium applications, but continue with potassium applications during the fruit fill stage. I'm curious as to where this would be applicable. I don't remember what I was thinking of several years ago, and also have had 8 hours of sleep in the last 72, so that might be a contributing factor. Um, but yeah, as there are increasing benefits. I just attended an event with our team in the Pacific Northwest, where we were focusing, the day was largely focused on fruit production and apple and cherry production. And we have just such an incredible team of agronomists. I'm so proud to be able to work with them every day. And one of our team members there, Kevin Tully, made a comment as we were out in the field looking at trees, talking about nutrient interactions and managing fruit quality. This conversation happened in a Honeycrisp block, and um, Kevin made a comment. He said that they have been able to correlate fruit quality, a lack of bitter pit, and storage quality to one thing, only one thing, and that is calcium, generous levels of calcium early at the bloom stage and during the cell division stage. And that if you don't get it early, and they missed it, they had this one several years ago, they had a very cool spring. And so soil temperatures didn't warm up early. The trees didn't really leaf out early. They had already blossomed and pollinated and were starting to fill fruit. And because of the cool spring, the tree development and the soil microbial development was delayed. And across the entire region, all farms, regardless of what they were doing, had low calcium levels in that cool temperature period because the trees weren't transpiring, they weren't moving water up from the root system upward. In other words, they weren't really transporting calcium from the root system up to the plant, and also soil biology wasn't doing a good job of releasing calcium. Whatever those various factors in interplay were, we don't know exactly what the drivers were, but the outcome was major challenges with fruit quality because of not having enough calcium during the cell division period. And the point that Kevin wanted to drive home was that you cannot recover later. Even though calcium levels were low, they applied large amounts of foliar applications of calcium, even during that cool season period, or even during the cool period, and then later on for the rest of the fruit fill period, they were not able to recover fruit quality with any amount of calcium application in any form on any of the farms that they were working on. And considering the growers that we work with are using dozens of different calcium products to try to achieve optimal calcium absorption for Honeycrisp apples, that's a very thorough and remarkable statement. So, yeah, that's my answer to your question. Calcium during the blossoming, pollination, cell division period, and having generous levels of calcium, there's just simply no replacement for that, and no situation that I can imagine where we would try to limit calcium. Question from Puerto Rico. Hi, Salvador. High bicarbonate irrigation water, considering its ability to interfere with the uptake of essential nutrients like calcium, magnesium, and iron, what measures can we take to counteract these effects and ensure optimal nutrient availability for our crops? So if you're dealing with irrigation water, you're probably, depending on the scale of what you're talking about, you're looking at injection of acids such as sulfuric acid or possibly a sulfur burner to counteract that. And also depends on how high your bicarbonate levels are, but those are the two common technologies that are an effective solution that I'm aware of. Question from Charles. I farm in an area that had 20 inches of rain from the 1st of May through June 30th, 2 months. Yikes. You know, in Northeast Ohio, at my home little mini farm homestead, we had 3/10 of an inch of rain from the 1st of May to June 30th. So we would have been happy to share. Trying to plant in these conditions led to terrible seedbed compaction and extreme lack of oxygen in the soil. What can a farmer do to combat these conditions? Charles, it's challenging for me to answer your question because I hardly have enough information. It depends on the crop. It depends on how severe the problem is. It depends on if the compaction is only a surface level or if it extends deeper. So there's a few too many unknown variables for me to give you a good answer. But if the problem is not too severe to be overcome, and if there is still a crop there and the opportunity to fill the crop, the approach that I would recommend is making a side dress application of Rejuvenate, or even a spray-on application of Rejuvenate, a microbial inoculant, perhaps combined with side dress nitrogen if that's necessary for the crop. Because one of the things that Rejuvenate is particularly known for is being able to flocculate and aerate and loosen soil very quickly. So depending on the severity of the problem, that could be a very rapid solution for the crop. And again, there's a lot of context that I'm missing. So is cultivation an appropriate tool for your system, your management system? Maybe, maybe not. I don't know whether that's something that could be recommended or not. Question from Gavin Myers: is manganese deficiency in a tissue test a good indicator of an iron deficiency? That's a good question, Gavin. Why are you still using tissue analysis? If you were using SAP analysis, you would know for sure. It's possible that it might be, but you could also just do a quick test of just making a small scale foliar application of a chelated iron and observing the plant response. If the plants become much darker green very quickly, then there probably is a need for iron, and that's a very common reaction. Your second question: what kind of scenario would be required to have adequate levels of manganese and deficient levels of iron when both are abundant in the soil profile? Adequate levels of manganese, deficient levels of iron. I can't think of one off the top of my head. I think that's what you're driving at with your first question as well. But it's important for me to point out that given the tremendous benefits that we've seen from the use of SAP analysis, I haven't looked at very many tissue analysis over the last 15 years. So is there a scenario where a tissue analysis manganese level could be used as an indicator for iron analysis? I don't have that experience. I don't suspect that would be the case, but I don't look at a lot of tissue analysis, so I don't know. Question from Doug: I've been working with AEA this year. The SAP tests we have done show that we really struggle to have good calcium levels. Is there something I should specifically focus on going forward? Doug, I'm missing a lot of context about your cropping system, crops, plants, so forth. But there are three things that I would suggest you keep an eye on. Boron levels in both your soil and in your plants, silicon levels in your crop particularly, and third, keeping your soil protected from direct sunlight. We spoke about this, I think, maybe on a webinar and a podcast interview with Greg Pennyroyal. We had this experience where when they're in their vineyard operation, when they started using mulch to protect the vineyard row, the soil in the vineyard row from direct sunlight instead of tilling it and having it exposed to direct sunlight, they had struggled for years to have adequate calcium levels. They were constantly applying calcium in the fertigation system with foliar applications. As soon as they protected the soil from sunlight, that meant they now had better soil moisture and cooler soil, so that allowed for microbial populations. Calcium delivery from the soil is really a function of good biology. So as soon as they created an environment where they had good biology, calcium absorption doubled with no additional further calcium applications. So those are the three things that I would pay attention to. Question from Stuart. Do you have experience working with Christmas tree crops? We do some. We found that the general rule of thumb among growers in the area is to expect about a 50% loss in the first year after transplanting. Whoa. I would find that an unacceptable rate. We've been struggling with rates higher than that. In looking at the soil tests, I have a few theories. The first is that we have good microbial biomass. Our fungal to bacterial ratio is extremely low. The second is that we have a heavy clay soil and our magnesium to calcium ratio is out of balance. And the third is that for these soils, our percentage of organic matter is roughly at 4% is too low to have enough water reserve for drought resilience. I'm thinking that fixing these would help correct our issues, but it doesn't really account for the rule of thumb. And I think good SAP analysis would be needed to try and figure that out. So, Stuart, there's a lot to unwrap there. But the very first place that I would look is I find that number to be remarkably high. The first place that I would look is what is the beneficial associated microbiome look like from these plants that are coming, seedlings that are coming from the nursery, and what would the benefits be of inoculating with the appropriate mycorrhizal fungi? I suspect doing that one thing alone would probably make a bigger difference than all the other things that you're suggesting combined, which, by the way, I think are good ideas. I think you're on the right track and thinking about the right things. But when you think about transplant shock, you need to provide plants with good moisture and water levels. Anyway, short version is from what I've observed with tree seedlings that are challenged, that are mass transplanted with perhaps less than ideal or less than optimal planting conditions. Good microbial inoculants go a long distance in helping plants to recover from that and to remain viable. That's one of the first things that I would look at. Question from Eugene. In literature, the optimum pH is 6.4. In Nova Crop Control reports, there are different values for different plants. For plum leaves, sap is 4.7 to 5.4. For blueberries, it's 3 to 3.3. Can you explain why? My pH values are higher. How can I adjust the pH of leaf sap? So, Eugene, our recommended levels or our targets for pH that we have developed are different from those of Nova Crop Control because we are targeting optimal plant performance and optimal health, as well as optimal yields. And our pHs tend to trend higher than those of Nova Crop Control as well. So if your pH levels are higher, that would not be an issue for concern. Ultimately, within the plant leaf and the sap pH that is being measured, we have to remember that pH is an indicator of nutrient balance. And so if you want to adjust pH, you simply need to address cation and anion balance. Once you bring your calcium, magnesium, potassium ratios to where they need to be, or levels to where they need to be, and the same is true of phosphorus and sulfur, etc., you will find that your pHs will tend to be in the zone where those plants perform at optimal levels anyway. So be more concerned about nutrient levels than about the pH, and the pH will take care of itself. Question from Mike. Hi, Mike. Once synthetic nitrogen is converted to an amino nitrogen, how long will it stay in that form if enough carbon is available to complete the process in 3 to 5 days? Oh, Mike, that's an awesome question. Speaking very generally and very broadly, the answer is indefinitely. And your qualifier is the way that you frame this question is a key qualifier. If enough carbon is available to complete the process in 3 to 5 days, then my translation of that is that there is enough carbon available in the soil profile to maintain it in that form, not just to complete the process, but to also maintain it in that form. As long as there is enough carbon available, it's going to remain in that form relatively indefinitely. Now, when I say indefinitely, we know that we will still have microbial processes occurring in the soil profile. We will still have the nitrification and the denitrification process, depending on what's going on with our soil microbial community. So there will be some nitrogen mineralization gradually over time. Depends on soil moisture, temperatures, microbial activity, etc. But that nitrification process will be measured in months at least, and possibly in years. So there's a lot of variables there, but what I can safely say is that it will stay in that form long for the remainder of that crop season for certain, and longer than that, most likely. Question from Walker. Chelation by acids like EDTA and EDDHA can help plants take up micros and nutrients. Glyphosate acts as a chelating agent but hinders micronutrient uptake. Could you explain the difference between the two? Yes, I can. And we had a glitch with a podcast episode. I think it was episode 118 from Frank Dean, where we talked about this. I don't know if that has gone back live yet or not, but it will quite soon if it hasn't yet. And I asked Frank this question. I already had known the answer, but I asked Frank this question because I wanted him to explain it. And it's worth listening, going back and listening to that conversation. But the short answer is that there are differences in chelation bond strength, um, where the just as a kind of a broad, general, overarching perspective, the chelation is a natural part of living systems all the time, with relatively weak chelation agents that have a weak bond strength, like amino acids and organic acids. These are all very relatively weak chelation agents, and they're used as a part of living systems all the time. Then you have slightly stronger synthetic chelation agents like the EDTAs, and then you have a glyphosate and some other herbicides and fungicides that are very strong chelation agents. The chelation bond strength is strong enough to pull minerals out of living tissues and out of enzymes and so forth where they are required and where they are functioning. So the difference in chelation between being beneficial or having a negative impact on living processes is a question of chelation bond strength. Question from Mark. Are there plans for an AEA silica product in the future? No, Mark, there aren't, because we already have one. It's called MacroPack. Um, MacroPack contains silicon. I am not certain that it's on the label because of, I'm sure, some regulator and regulatory requests somewhere. So MacroPack does contain silicon. I think if you were to do an elemental analysis on it, it's somewhere in the neighborhood of about 2%. Question from Edward. I'm growing wheat for seed. When receiving new seed to multiply, what is the best way to ensure good levels of bacteria and nutrients? Use Seed Flare and BioCoat Gold. There's an easy answer for that question. General seed treatment or a tea made from a mash of last year's seed. What I'm reminded of, your second question reminded me of the story. I discussed it in my podcast interview with James White, and I've heard the story before of the practice of several of the Iroquois Indian tribes where they selected plant species um, that had a similar microbiome to their corn seeds, and they would grow those or collect leaves from those and turn them into a poultice and germinate or soak the corn seeds in that before planting them. And Dr. White also described a process by while they're taking an extract from an apical meristem from the growth tip of plants that are growing and using an extract of that to inoculate seeds and to transfer a microbiome from one generation to another. So I would suggest you listen to that episode, and that can give you some insights into how to transfer microorganisms from one set of seeds to another. It's a very good question. Question from Dan. We have a regenerative farm in Texas with pasture poultry, grass-finished beef. Animals are moved daily. Bermuda pasture that is being taken over by woolly croton. That's a plant that I'm not familiar with. We've tried to control it by mowing, but every year it increases. Any questions on how we can control these weeds? So, Dan, the way that I would approach this, there's several levels of questions that we can ask. If you are mowing it and the population is increasing, what has been the timing? What is the stage of plant development of mowing? And would it be more impactful to mow earlier or later or at a different stage of plant development? That's one level of question that we could ask. Another question that we could ask is, what plant family is this species from? And can we identify other plants from the same family that are actually valuable and that would benefit us in growing and actually provide a crop for us and provide some of the microbiome benefits that plant is providing and effectively give it a reason to not continue expressing itself. And then another level of question that you can ask is, what is the mineral profile that this plant thrives in, and what is it specifically trying to bring from a mineral perspective? And you can identify that by conducting a sap analysis or a tissue analysis on this plant, although I would recommend a sap analysis, and observing which minerals this plant is particularly high in. So it's interesting that some of these plants which really proliferate have extremely high levels of some nutrients, usually one or two, that are as much as an order of magnitude higher than other plants in the same area. And so that is an indicator that this plant is trying to fix, let's say, copper levels, or trying to fix calcium levels or manganese levels. And there's two things that you can do in that context. One is you can address those minerals in the soil profile. And two, you can actually foliar feed those quote unquote weeds with that mineral. If the plant is very high in manganese, you can simply add more manganese, and that will shut down its vitality in many cases. Follow-up question from Mike. Is a 10-to-1 nitrogen to sulfur ratio enough when converting synthetic nitrogen to amino acid nitrogen, since 50% of ATS is elemental sulfur and not immediately available? That's a good question, Mike. That's a very good question. What we know for certain, what we have measured, is that we get dramatically reduced nitrogen leaching when we add that combination, our total nitrogen efficiency program combination. It would be worth measuring that. It wouldn't be that difficult to measure at specific intervals with a soil analysis, to measure the nitrate, the ammonium, the urea, and the organic nitrogen fractions within a certain time period after an application. I suppose I had always assumed that the addition of our nitrogen efficiency program, the Rejuvenate, and the addition of that sulfur would, well, we know the response that we see in plants, and I had assumed that that would translate to all of that being converted. And of course, actually, I say when I assumed that, I had assumed that that would generally be true across most operations, because it does depend on what's happening in a given soil setting with with available carbon levels, with other nutrient profiles that are going on, other sulfur availability in the soil profile, and so forth. So that's an interesting question, and I don't know the answer to that, but it would be very worthwhile testing it, and it wouldn't be that difficult to measure that and to see what's actually happening and what's actually going on. It's an outstanding question. Question from Zachary. Have you ever experimented with inoculating worm farms with your engineered biology, or the effects of adding other fertilizers to worm productivity? I have not, but I know of several people that may have. And first of all, our biology is not engineered, or at least not in the way that that word is sometimes misconstrued. But in general, greater microbial species diversity is better than fewer, as I understand it. And that species diversity is driven in agricultural ecosystems by plant diversity. So plant diversity drives microbial species diversity. We need to begin thinking of plants as that every plant vectors its own associated microbiome, and that plants are actually the best and highest form of microbial inoculant. That's the way that we need to begin thinking about it. So that's a wrap for all the questions that have come through. Thank you, Phil, for helping me moderate the questions. Thank you to all of you for being here. I hope you find the information valuable and useful. And I really enjoyed these Q&A sessions. Thank you for giving us this feedback and asking these really great questions to stimulate all of our learning and development. And I look forward to chatting with you again in the future, and hopefully seeing you at some events out in the field this summer. Thank you all. Have a great day.